Hello and welcome back to another episode of Math with Stone. Today we're going to be determining the end behavior of graphs. We're going to be graphing polynomials. We're going to be doing all sorts of things, and we're going to avoid using the graphing calculator while doing it. Okay? So, in order to determine the end behavior of a function using the leading coefficient and the degree of polynomial, it's really annoying typing every single thing in here just to be able to do the end behavior. All right? Which is why we're focusing without the graphing calculator today. There are only 4 possibilities, and I have all 4 of them here. If it is an even exponent, like it is here and here, if it is an even exponent, an even degree, as the biggest degree, then it is going to behave like a parabola, and it is positive here. So that means that this graph will act like a positive facing parabola. We don't know what's going to happen here. We don't know. That is a mystery, but that's not the part that matters because the end behavior is still here. Okay? So, it's a positive facing even degree, so it will behave like a parabola. It will be going up, up. And that means that as x approaches infinity and x approaches negative infinity, f of x is doing what? And f of x is doing what? That same setup from before that we had earlier on in the year. So on the right side, we are going up, and on the left side, we are going up. So both of these would be positive infinity for the f of x, which is the y values. All right? What about number 2? We got g of x here. Well, g of x has a even degree, but it's negative. So this is going to be behaving like a sad-facing parabola. It's going to be sad on both sides. We don't know what's happening in the middle. This could be doing all sorts of craziness, but that's not the part that matters. This is the end behavior right here. So we got x approaches infinity, x approaches negative infinity. This is the right side on the x approaches infinity. This is the left side as x approaches negative. As f of x approaches what? As f of x... Oh, it should be g of x. G of x approaches what? Well, they're both going down. So on the left side and the right side, y values are going down. So that's why I wrote negative infinity there. If it's an odd degree function, because this is odd and this is positive, it will behave like a line. So odd degree behaves like a line in opposite direction, so you need something that has a positive sloping line. So it's going to be going up from left to right, and we won't know what's happening here. We don't know what's happening there, but we do know it's going up from left to right. So that means on the right side and the left side, we can fill in our f of x's. Oh, it's h. I keep forgetting the letter. H of x. Okay, so on the right side, we are going up, so positive infinity for that. On the left side, we are going down, so that would be negative infinity for that one. So left side, negative infinity for x, we're going down. Right side, positive infinity for x, we're going up. Okay? Here, we got a negative, and we got an odd degree polynomial. So it will behave like a sad facing negative sloping line. It'll be going down from left to right. So x approaches infinity, right side, x approaches negative infinity, left side. Q of x approaches what? Q of x approaches what? Well, on the right side, we are going down. But on the left side, notice how the graph is going up, so that would be positive infinity for that one. Okay, for the next problems, we need to sketch the graph of the function. We're not going to get a perfect graph. We're just sketching it without a graphing calculator quickly. Okay, so in factored form, this is going to go really easily. We're going to pay attention to our end behavior. We're going to pay attention to our zeros, and occasionally we will be paying attention to our y-intercept. So here, our zeros are going to be -4, change the sign, -1, change the sign, and 5/2, change the sign, which is also 2.5. Okay, let's plot those 3 zeros at -4, at -1, and at 5/2, which is 2.5. Ask yourself, even degree or odd degree? Well, the amount of zeros also determine that. We have 1, 2, 3 zeros, so we will have an odd degree polynomial here. Not only that, but it is going to be a positive in front, so it's going to be going up from left to right. So we are going to be able to curve this starting down here and ending up there, up through the -4, down through the -1, then back up through the 5/2, and then ending up top. Okay? If you want to, you're also allowed to plot the y-intercept. The y-intercept is sometimes way off your graph, and it kind of is this case too. If you multiply all your constants together, the 4, the 1, and the -5, you end up with -20 for the y-intercept, or if you plug in 0, you can get -20. That might help, but normally that's going to be off your graph and not really the focus of what we're doing. We want to be able to know from the graph which way is it facing, real quickly do a rough sketch based on the zeros and the degree of the polynomial. Okay? This next one, we have -4 for our 0. We have -1 and +3, but because it's squared, it is a repeat 0, and it will bounce. Anytime it is squared, it's a repeat, which means you have 2 zeros at 3, which means it's going to bounce off of that because this should be a 1, 2, 3, 4 degree polynomial, an even degree of 4. So with that in mind, let's plot the zeros. We got -4 again. We got -1 again. We got +3. If it is an even degree and negative in front, it should be a sad facing parabola type of thing. So it's going to have to go through the -4. It's going to have to go through the -1, but it's going to have to bounce off of the 3. Anytime it's a repeat 0, it bounces. It does not go through. We learned a little bit about that in the last video. So it's going to bounce off the 3, and that would allow it to complete the double sad on both sides, the left and the right side of this polynomial. If you wanted to figure out the y-intercept, it's way off the graph. It would actually be at like 9 and then times 4. It's at 36, so I don't think that's worth it. So we're going to focus on the zeros and the end behavior and the bouncing aspect of these. All right? Next one, we got x squared plus 4 and an x minus 3. Well, x squared plus 4 is equal to 0 means that x squared would equal -4 and x would equal plus or minus 2i. Uh-oh. I, imaginary values, are not plottable on the graph. Okay? So we do have an actual 0 at +3 from this guy. But that's the only 0. We also know that this is an odd degree. We can count up the x's. We got 1, 2, 3, so our degree is odd, and it is facing down, so it should be a negative sloping line. So with that being said, you should not make it just a line. It's not a line. It's next to the third. It should go through the -3. And then a lot of times what you'll see people do to represent that there was some imaginary solution, you'll see like a bend somewhere in the graph. Without a graphing calculator and without calculus, it's very difficult to figure out where that bend is. But to prove it to you, let's see maybe what it looks like in the calculator. I'm going to graph this one for you just so you can see it. All right? To see that imaginary plus or minus 2i is an answer, but it's not something that is going to be just plottable from some intuition. See how it kind of bends a little bit up there? If I zoom out, you'll see a bend. There's the bend. Okay, so slight bend. That's just just to kind of tell people, you know what? I know there's an imaginary 0 around here somewhere. Okay? I'm not worried about where the 0 is. I am worried maybe to put the bend to show me. Plus the 3. Don't forget the 3, because that one's real. Next one. This next one, oh no, we got an x to the third. We got a minus 2x, and we got a plus 4. Okay, so how are we going to graph that without a graphing calculator? We would first need to find the zeros of the graph. Now, if you don't have a graphing calculator, which for this we're trying to aim not to, we would have to just try synthetic division. I'm going to try a 1 because normally you can divide by 1. The possibilities are 1, 2, and 4, positive or negative. So there aren't many options. 1, 0, negative 2, and 4. We're missing that x squared term. Bring down the 1, multiply 1, add 1, multiply 1, add. We get negative 1. Didn't work. This is not going to be a remainder of 0. So let's try another one. We're going to try negative 1. Let's try that out. We got 1, 0, negative 2, and 4. Bring the 1 down. 1. Multiply. We get negative 1. Add. We get negative 1. Multiply. We get positive 1. Add. We get negative 1. Didn't work either. Okay, so what's the next one on the list? Let's try 2. We got a 1, a negative 2, a 0, a negative 2, and a 4. Bring down the 1, we get a 1, multiply 2, add, we get 2, multiply 4, add, we're going to get 2. Oh, so close. It's going to take the 4 guesses here. 1, 0, negative 2, and 4. 1, multiply negative 2, add, we get negative 2, multiply, we get 4, add, we get positive 2. There we go. We finally got a 0 at negative 2. Whew. Okay. With that in mind, we are going to have to figure out what the remaining zeros are going to be, knowing that negative 2 worked. Now, if we have x squared minus 2x plus 2 is equal to 0, that is not factorable, and it ends up being imaginary. Okay, we've already tested out all the other ones. We know that this doesn't multiply to 4 and then add to anything else. And the only possible zeros were 1, negative 1, 2, negative 2, and 4, negative 4. This doesn't factor into 4 and negative 4. So that means that this has to be 2 imaginary solutions, which means that we have the only real 0. Okay, so we can graph with that 0 of negative 2. And we know that this is an odd degree and it's positive, so it's going to have to go up from left to right. And we have a kink in there to represent some sort of 2 imaginary. Okay? So that's those. The next and probably easier thing to do would be to write the function that represents the graph given the 0. So this we have done in the past. We did it in the quadratic unit. But now we have to do it in the polynomial unit. You're going to start with your 0. So we have y equals, change the sign, x plus 1. Change the sign, x minus 3. Okay? From here, it looks like it bounced on the 3. So I'm going to write x minus 3 squared because it also is an odd degree. So it's going to need to have an odd amount of x's. So here we got 1, 2, 3 x's. It seems to work out. All right? Here, you may notice on the next problem, we got 1, 2, 3 already there. The thing that you need to figure out is what is the value in front? What is the leading coefficient? Is it positive? Yes. Is it 2 or 1? We don't know. We need to plug in this point for x and y. There's always going to be needing, if your teacher wants it, an extra point there for you to plug in to solve for a. So that's what we're going to do now. We're going to plug in 9. We're going to plug in 0 for x. And we're going to probably confirm that the a value is 1. But let's just confirm it. A is equal to 0 times 1. That would be 1. And then negative 9 squared. Oh, a is not 1. We have 9 is equal to a times 81. A would equal 1/9. Because 9 divided by 81 is 1 over 9. So this was, in fact, not 1. I thought it would be. Look at me. X plus 1 squared, x minus 3, parentheses, that's not squared. There we go. So x minus 1 and then the x minus 3 quantity squared. Okay, last one for the day. This one, also very important because it is unlikely that you're going to write x minus 0.5 or x plus 0.5. What most people will do for that would be 2x plus 1, because you would start out with x, change the sign, plus 1/2, All right, 0.5 is the same thing as 1/2, and then you put the 2 in front. So this would be the format that most people would see it in. Change the sign of your 2 and change the sign of your 3. You got your a, you got your y equals. Okay, so that negative 0.5 was a 1/2. We changed the sign of the 1/2 to make it positive 1/2, and then you bring the 2 in front. This is the format that most multiple choice, as well as your teachers, would probably expect. We have to plug in the 0 for x and the 6 for y to see what the a value would be equal to. 2 times 0 plus 1, and then 0 minus 2, and then 0 minus 3. Let's see what this equals. I think the a in this case is positive 1, but I could be wrong. I thought it was positive 1 last time. And negative 2, and negative 3. When we multiply all three of those numbers together, you get a times 1 times negative 2 times that. You get 6. Oh, slightly off the page. Sorry. 1 times negative 2 times negative 3 is positive 6. So a times 6 is equal to 6. When we divide, you get a is equal to 1. Okay? So with that in mind, you would reinsert in that a value of 1 and then be able to box your answer. Okay, that's going to do it for this one. Until next time, my friends, I will see y'all later. Bye.